In this lesson, we're going to do a couple examples relating with problems relating to cofunctions. So they want to rewrite cosine of 52 into an equivalent piece. So we're looking to kind of use one of these relationships. So cosine of angle is going to be equal to sine of 90 minus that angle. So there's always multiple ways to go about doing this. I like to remember the fact that cofunctions are complementary. And so I treat it a little bit different than maybe the definition is going to be. So cosine of 52 is going to be equal to sine of something. Now that something, this idea of complementary, is, here's how I approach it, where I take 52 plus this angle that we don't know, we'll call it a question mark, is going to be equal to 90. That's the idea of being complementary. Two angles make 90. So if I solve for I don't know, then I move 52 over. And so question mark is going to equal 38. So sine of 38 degrees. Now, is that the only way? Of course not. You could have just taken 90 minus 52 right at the very beginning, and you're going to get yourself 38. I'll show you why I do this on something a little bit more complicated when your angle has a variable mixed within it. So sine of A is going to equal, sine of A minus 11 is going to equal cosine of, I don't know. But I treat it exactly the same. I'll take this A minus 11 plus another angle measurement, which I don't know, is going to be equal to 90. And I solve for I don't know. So to solve for I don't know, that means I need to take these two values and bump them over to the other side. So I'll subtract A and add 11. I will subtract A and add 11. So I'll add the 11 underneath the 90 just because they're going to be like terms anyway. So this angle is going to be 101 minus A. So cosine of 101 minus A is going to be equal to sine of A minus 11. And you could test it out, you could put in an angle, whatever you'd like to do, but again, it should be something more like this, of whatever you plug in here. If A is 30, then A is 30. See the math and double check that that angle and that angle both add up to 90. We'll do one more. This time the directions are just a smidge different. You are going to solve for theta. Alright, so our problem that we have is cosine of theta plus 4 is equal to sine of 3 theta plus 2. Alright, so a little bit different, where you already know that cosine and sine are equivalent to each other, so we're using this group right here. It could have been secant and cosecant, could have been a tangent and a cotangent. It really wouldn't matter what you put here as long as they're the right kind of combination. But you're trying to figure out what theta is. So again, I treat it exactly the same as this one, but this time I don't have this unknown piece. So I can just say theta plus 4. So this angle plus this angle, so more this style, right? This angle plus this angle is 3 theta plus 2. So this angle plus this angle should add up to 90. And then I solve for theta. So I put my 3 theta and theta together, that's 4 theta plus 6 equals 90. Subtract 6, 4 theta equals 84. Divide by 4, divide by 4. Theta is going to equal 21. Now, just to make sure that I'm right, I could take the 21 and put it in here. That's actually going to be a 25, so I'll just do a little side work for a second. And these two angles should add up to 90, so let's double check. So that's 25. This is going to need to be 65 in order for this thing to work. So 3 times 21 is 63 plus 2 ends up being 65. And those two add up to 90. And that's what's supposed to happen. All right, so that was a few examples relating cofunctions.